class. Now in this session we are going to learn that how to integrate the exponential function, right? We know that the derivative of exponential is exponential, and then we need to find out the power derivative of its power, right? In this example you can see that the integral of exponential is exponential, but again the same question arises when the derivative of its power is written next to it. Now you see that the same strategy, the same working, that the derivative of its part should be present next to it. We are doing the whole integration with this one concept only, right? We have done the integration by functional integration, we have done trigonometric, and now we are doing exponential with the same strategy, that the derivative part should be present next to it. Now on the right side of the screen you can see there are examples here. So in the first example it says integral of 2x plus 1 dx. The integral of exponential function is integral, but when the derivative of its power written with the next to it. So we need to integrate 2x plus 1 dx, right? Now the derivative of its power, it will be 2, and we need to multiply it by 2 by 2. So now this function here, it's ready to integrate because the derivative of its power is now available in the question, and this denominator 2 I will bring it outside the exponential sign. So now my function is e to the power 2x plus 1 times 2 dx, which is ready to integrate. And now the integral of exponential is exponential, and this divided by 2 as it is, and plus c. So that is the integration of exponential function. Alright, so with the same approach we are going to start exercise 20.4. Question number 1, we have different parts here, but we are going to select few of them. It's B, D, F, H and J. These 5 parts we are going to solve from question number 1. So starting with the part B, you need to integral e to the power 2x dx, right? We know that the integration of exponential function is exponential when you have the derivative of its power. So for B part, e to the power 2x dx, the derivative of its power, it's 2, and we need to multiply it by 2 and 2, right? So now this function is ready to integrate, and this denominator 2 is outside the exponential sign. E to the power 2x is e to the power 2x, so you can say that it's e to the power 2x divided by 2 plus c. That is your first part answer. After that, part D, integral of e to the power minus x dx minus integral of e to the power x dx. Alright. So for this part, the derivative of power minus x, it's minus 1, right? So we need to multiply and divide it by minus 1, and in this case the power is x and the derivative of x is 1, so there is no need to multiply with any number or sign. Now this one, the integral of e to the power minus x is e to the power minus x, and this denominator minus 1 is already here, minus e to the power x, it's e to the power x, and plus c. So we can say that it's minus e to the power minus x minus e to the power x plus c. Alright, so moving towards next question after D, it's part F. It says 2 e to the power 1 upon 2x. Again we need to integrate the function. So the power is 1 over 2x. If you derivate the power, the answer is 1 over 2, right? So we need to multiply and divide it by 2 here. So what I will do, 2 integral of e to the power 1 upon 2x, and we need to multiply and divide it by 2 dx, right? Now the function e to the power x and its derivative is this part, right? Now the function is ready to integrate. and this 2, if we take outside the integral sign, so 2 2s are 4, so it's 4 e to the power 1 upon 2 x times 1 upon 2 dx. The integral of exponential function is exponential, and we need to apply plus c here. Alright, after part f, it's part h here. It's 3e1 minus x. No need to write down any solution. I will give you time to write down all the questions in your lecture copy. So we need to integrate e to the power 1 minus x dx, right? The derivative of 1 minus x, it's minus 1, so we need to multiply e to the 1 minus x with minus 1 and minus 1 dx, right? Now the function is ready to integrate because the derivative of its power is right next to it. So this minus 1 in the denominator, we are going to take it outside, so minus 3 e to the power 1 minus x and then plus c. That is your answer. And after part h, it's part j here. It's 4 e to the power 1 upon 2 1 minus x. Alright, now what we need to do, first we need to write down these 4 solutions in your copy and then start the 5th part by yourself. And for all those questions and parts, you have a time of 3 minutes, so stop. Alright, so it says 4 integral of e to the power 1 upon 2 1 minus x dx. The derivative of power is minus 1, right? So we need to multiply and divide it by minus 1. Now this function e to the power 1 upon 2 1 minus x and minus 1, this function is ready to integrate now. So this minus 1, we need to bring it outside the bracket, integral, sorry. So it's 1 upon 2 1 minus x and plus c. That is your answer. Alright, so if you have done in this manner, so that is a little bit wrong here. And why it is wrong? It is wrong because the power is not 1 minus x. And why is it so? Now listen to me carefully. It says e to the power, when you multiply the bracket, so it's 1 upon 2 minus 1 upon 2x. Alright, first if you multiply the power, so it will be like this, right? Now you will see that the power is 1 over 2x. So if my question is 4 e to the power 1 upon 2 1 minus x, so I know that the derivative of power, it's not minus 1, it's minus 1 upon 2, as you can see here, right? So we need to multiply by minus 2 and minus 2. Alright, and why is it so? If I write in this way, 4 and this minus 2, when you take it outside, it will be minus 8, right? So now it's minus 8 integral of e to the power 1 over 2 1 minus x, it's 1 over minus 2 dx, right? Now the derivative is right next to it, the function is ready to integrate, so it's minus 8 1 upon 2 1 minus x plus c, and that is your final answer. Alright, the solution which I showed you earlier, that is a very silly and common mistakes, appeared very oftenly in such type of questions. So make sure that when you have this type of power in which there is a multiplication, so first we need to multiply the bracket, so you have a clear idea that what is actually the power of exponential, or from which what should be the constant we need to multiply to find out the integral of exponential function. So moving on towards the next part, next question. It's question number 2, and the parts we are going to attempt, it's D, D, E and F. Alright. Firstly, they are all definite integrals. So for part B, from 0 to 1 e to the power 2x dx, right? Firstly, what is the derivative of power 2x? It's 2, so we need to multiply and divide it by 2. So I can say that it's integral from 0 to 1 e to the power 2x. The 2 in the numerator, I'm going to write it down right next to it, and the 2 in the denominator I will take it outside the bracket, right? So the exponential of power, integral of exponential is exponential when the derivative of power is written with next to it. So now the condition satisfies here. So now the integral of e to the power 2x is integral e to the power 2x, and the limits we have, it's from 0 to 1. So it's 1 over 2. Upper limit it's e to the power 2 minus lower limit it's e to the power 0. You can say that 1 upon 2 e to the power 2 minus 1. Alright, so we are going to leave in the same form, and that is your answer here. Alright, after part B, let's start with part D. No need to write down the solution right now, I will give you the time for that. So now it's integral from 1 to 2 e to the power 1 minus x dx, right? So the derivative of power is minus 1, so I'll say that e to the power 1 minus x minus 1 dx integral of 1 to 2, right? Now the derivative of power is right next to it. Now the function is ready to integrate, and this denominator minus 1 I will take it outside the integral sign. The exponential, it will be e to the power 1 minus x, limits we have it's 1 and 2. Now I'm going to apply limits here. So upper limit is 1 minus 2 minus lower limit is 1 minus 1. So it's minus 1 e to the power 1 minus 2, it's minus 1. E to the power 1 minus 1 is e to the power 0. So it's minus 1. E to the power minus 1, it's 1 over e minus 1. Or we can multiply with the negative sign, so it will be 1 minus 1 upon e, and that is your answer. Alright, after part D, moving on to the next one, it's part E here. Integral of 0 to ln2, it's e to the power 3x dx. The first step is again the same, that the exponential integral is exponential, but when we have the derivative of its power. So derivative of its power is 3, so you need to multiply and divide it by 3. The 3 in the denominator I will take it outside the integration, so it's 1 upon 3 0 ln2, it's e to the power 3x times 3 and dx. Now the derivative of power is present with the function, so now the function is ready to integrate, so it's 1 upon 3. The integral of exponential is exponential, and the limits we have it's from 0 to ln2. So 1 upon 3 outside, e to the power 3 instead of x it's ln2 minus e to the power 3 instead of x it's 0. Alright, so 1 upon 3 e to the power 3 times ln2 minus e to the power 3 times 0 is 0, and it is equals to 1. Alright, to solve this function e to the power ln2, so first we need to find ln2, that is 0.7 times 3, it's 2.097. So I can say that 1 upon 3 e to the power 2.08 minus 1, and e to the power 2.08, that will be 8 minus 1, it's 7 divided by 3, and that is your final answer. Alright, so we have attempted 3 parts, B, D and E, and now before proceeding to the next one, what you need to do, you need to write down these 3 solutions in your copy and attempt part F here as well. And for these 4 parts you have a time of 3 parts you need to write down, and 1 part you need to attempt. So I think 5 minutes. You have a time of 5 minutes to give it a try for part F and write down all 3 solutions in your copy. So start. Alright. So for part F, I hope that maybe you had tried some of the thing. Part F, integral from 0 to ln3 e to the power x dx, right? That is your question. Now it's quite simple because the derivative of power is already present to the next to it, so there is no need to multiply by any constant. We just need to apply the limits here. So integral of exponential is integral, and the limits we have is 0 and ln 3. For upper limit it's ln 3 minus e to the power 0. Alright, so e to the power ln 3 you can find out, and that is equals to 3 minus 1, it leads to 2. Alright, so that is quite an easy question. I hope that all of you have done it. Moving on to the next one. It's question number 3. Find y as a function of x given that dy over dx is equals to 1 minus 3 e to the power x, and that y equals to 4 when x is equals to 0. So what do you think we should start with? What we need to do first? If you observe that it says find y, right? So we need to find out y here, and what we have, it's dy over dx, right? So if I write in this form that dy is equals to 1 minus 3 e to the power x dx, right? We need to find y, that means we need to eliminate differentiation here. So we need to apply integration on both sides, right? So for left side we have y is equals to integral of 1 minus 3 e to the power x dx, and that is it, right? We need to integrate the function. So firstly I will eliminate, I will expand the bracket here. So it's integral of dx minus 3 integral of e to the power x dx, right? So integral of x is x minus 3 e to the power x, and the thing you need to remember the most is that you need to write positive c here, because we are dealing with indefinite integral, right? To find out the value of c, we have the value of y and x to find the value of c. So I will place the value of y as 4 here, and x is 0. So it's 3 e to the power 0 plus c. 4 equals to 3 plus c, and you got the value of c, that is equals to 1. When you have the value of c, again in the same equation it will be y is equals to x minus 3 e to the power x plus, instead of c I will place the value and it's 1. Alright, but there's one mistake, and what is that? When I was solving it, the sign with c is 3 is negative 1, right? So that is minus 3, and when you shift negative 3 on the left side, it's positive 3, and that is 7. So it is 7, and that is your answer. So whenever you have dy by dx and it says to find out the value of y, so keep in mind that for this or for such type of questions you need to apply integrate on both sides. From dy you can easily find out the value of y or the function of y simply by applying the integration. So first write down the solution in your copy, and for that part you have a time of 60 seconds to start to begin. Alright, so I hope that all of you have a clear idea how to solve such type of questions, and we are going to attempt another one. It's question number 4. Alright, so it says that express y in terms of x, same type of questions, and you have dy over dx is equals to 2 e to the power minus x. You have the value of y and x. It is the same one like we have done previously. So first we need to give it a try, and for that part you have a time of 2 minutes, so start. Alright class, firstly if I write in this form dy is equals to 2 e to the power minus x dx, it is the same thing, right? But we know that to find out the value of y we need to integrate on both sides. So on my left side, integral of dy, it's y is equals to the integral of e to the power minus x. We know that we need to multiply and divide it by minus 1 because the derivative of power is minus 1, right? So it will be minus 2 e to the power minus x, right? And we have plus c, that is unknown, and for value of c we have the values of y and x. So the value of y we have, it's minus 1, so minus 1 is equals to minus 2, x is 0, so it's plus c, minus 1 equals to minus 2 plus c, and the value of c we have, it's 1. Alright, now we need to place the value of c in this equation. So y is equals to minus 2 e to the power minus 6 and c is 1. Alright, so that is your answer. So I hope that all of you have a clear idea that how to integrate the exponential functions and how to find the equation y from dy over dx. Alright, so moving towards the next question. Question number 5. Find y as a function of x given that dy over dx is equals to e to the power 2x, and that when y is 6, x is equals to ln 3. So again a similar type of question. Now at this time I'm sure that you can do it easily, so give it a try. You have a time of 2 minutes to start. Alright, firstly if I arrange the equation, so dy is equals to e to the power 2x dx, right? I need to apply a sign of integration, so integral of dy, that will be y. So it will be y is equals to e to the power 2x and dx. To find out the integral of e to the power 2x, we need to find out the derivative of its power. So it's 2 and 2. Now my function is ready to integrate, right? So it will be e to the power 2x divided by 2 plus c. To find out the value of c, we have the value of y and x here. So y is 6 is equals to e to the power 2x is ln 3 divided by 2 plus 6. So 6 is equals to, now we can find out the value of e to the power 2 times ln 3. So ln 3, it's 1.09 times 2, it's 2.2, and e to the power answer is 9. So it's 9 upon 2 plus c. 6 is equals to 9 upon 2, it's 4.5 plus c, and 6 minus 4.5 leads to 2.5 equals to c. Now my final answer, it will be not this one. We are going to use this equation. So y is equals to, not this one, this one. Y is equals to e to the power 2x upon 2 plus c is 2.5. Alright, and again 6 minus 4.5, it's 1.5. So the answer is 1.5, and that is your final answer. Alright, so I hope that all of you now have a clear idea how to solve such type of questions, and as a homework you need to attempt question number 6 of the same exercise, right? And inshallah in the next class we are going to touch some of the past paper questions, that is basically for revision of the entire topic. So make sure that before next lecture all of you must have a good command on all the subtopics of integration which we have discussed so far, because then you are easily understand the past paper question. Alright, so I think that is enough for today class. See you next class. Take care.